This is a picture here of Gilbert and Lewis, who we know because of the Lewis electron dot structures. What I want to talk about really quickly is something called Lewis acids and Lewis bases. Now we know whenever we have a covalent bond, that is formed when two atoms share a pair of electrons. And usually what happens here is that one electron came from one atom, and then the other electron came from the other atom to form a bond. We do have situations, though, like here, when the ammonia forms ammonium ion, where a bond is formed, and what happens in this bond is this pair of electrons is being shared between both atoms. Now, we can have that kind of a situation, and we call that a coordinate covalent bond. So this is where a bond is formed between two atoms, where the pair of electrons is being donated by just one of the atoms. So usually each atom comes in with one electron, but you can have a pair of electrons being shared, but they both came from the same atom, and that's called a coordinate covalent bond. Now when we have that situation, here's where we define a Lewis acid and a Lewis base. Whichever atom came in and donated that pair of electrons, then that is the Lewis base. And any atom that came in and is accepting that pair of electrons, that's the Lewis acid. And you can see what's going on here is Bronsted-Lowry would also have said that this ammonia is a base because it is accepting the proton. So a Lewis base would also be a Bronsted-Lowry base. What's kind of powerful about the Lewis acid-base reaction is that we have a situation where if there is no proton being transferred, we can still talk about this being an acid and a base. So we can see what's happening is we have this bond right here that's being formed between these two molecules, and when that bond is formed, the pair of electrons that's being shared came from the nitrogen. So we're going to say that the NH3 is the Lewis base, and the BF3, because it has an empty orbital on the boron, that is the Lewis acid. Now Bronsted-Lowry would have had trouble with the BF3 being the acid because there's no proton that is being donated. We have our definitions then. Here's our Lewis acid is an electron pair acceptor, and that's our boron, and a Lewis base is the electron pair donor. Now you need to be a little bit careful here because in this case we're saying this is an electron pair acceptor for the acid, where we're talking about Bronsted-Lowry acid, it was the proton donor. So in one case the acid is the donor, donating a proton, and now we're saying that the Lewis acid is the acceptor, the electron pair acceptor. So just that wording sometimes gets people a little confused. So a Bronsted-Lowry base is a proton acceptor, but a Lewis base is a donor, electron pair donor. And this happens for the special case where we have a coordinate covalent bond. A mnemonic that I've seen for this is like a little bit of graffiti. It says have pair will share, signed Lewis base. So in this situation again, here the nitrogen has a pair of electrons to share, and so that's going to be our Lewis base. And the empty orbital is going to be our Lewis acid.